Hi student, exercise number 2.2, question number 7. Find the greatest number consisting of 6 digits which is exactly divisible by 24, 15 and 36. We want to find the greatest 6 digit number. That number is divisible by each of this 24, 15 and 36. First we have read what is the 6 digit number, greatest 6 digit number, right? The greatest 6 digit number is 9999. This is the greatest 6 digit number. Now we want to find the LCM for this number 24, 15 and 36. First we have to find the LCM, and then the LCM should be divided the greatest number. Let's see that. Here LCM of 24, 15 and 36. If you take LCM of 24 is 2, 6, again 2, 3. So we get 1. So it is 2 into 2 into 2 into 3, the factors of 24, right? Then 15 is 5 3s are 15. And then 36 we have the factors 2, 18, again 2, 9, 3, 3, 3, 1. So 2 into 2 into 3 into 3. Now we want to find the LCM for this number. See, here we have 2 cube, right? LCM of 24, 15 and 36. This can be written in the form of 2 cube into 3. Here we have 2 square into 3 square. LCM means we have to take all the elements with highest power, right? So first I choose 2 and then 3, here we have 5. Now we go to the powers. The highest power, here we have 3, here we have 2. So we take 3, and then for 3, here we have power 1, 1. For this term we have 2. So we take the 3 power 2, and then 5 we have only 1 term, right? Now 2 cube is 8, 3 square is 9 into 5. Then 8 5s are 40, and then 40 into 9 is 360. That is 4 9s are 36, and then 0, 360. So the LCM of this number is 360. Now we want to divide the term with the greatest number. We want to find the greatest 6 digit number which is divisible by all these 3 numbers, right? So we are going to divide the term by the LCM. The LCM is 360. If you divide the term, so 360 into 2 times we get, right? 7, 20. When you subtract this, we get 9, 7, 2. Next we take one digit 9. In 2799, right? Here we have 36, here we have 279. At most it will be a multiple of, just check the number. Here it is 360, right? Here it is a 360. So we get clearly this is 7 times if possible. 360 into 7. 360 into 7. 7 zeros are 0. 7 6 are 42. 2 remainder 4. 7 3s are 21 plus 4 is 25. So here we have 2520, right? So clearly it is up to only 7 terms only, right? 7 times if we multiply we get 2520. Subtract this term we get 9, 7, and here we have 2, 2, 7, 9. So the next term is 9, right? Then see here also we have 2, 7, 9, 9. Again the term will be the same. So it will be again 7 times, right? So it goes on 7 times. So we get 2520. Subtract again this. If you subtract the same term, we get 2, 7, 9. The last term is 9 here. Then again we have to multiply by 7. We get the same number 2520. When we subtract this, we get 972. So 279 should be subtracted from the greatest 6 digit number. Now the greatest digit number, the greatest 6-digit number, greatest 6-digit number which is divisible by the number 24, 15 and 36 is, we have to subtract this remainder in the 6-digit number, right? The 6-digit number is 9 minus 279. If you subtract this, here I put the term 279. If you subtract this term, 7 minus 9 minus 7 is 0, 9 minus 7 is 2, 9 minus 2 is 7, and then 9. So this is the number. So 720, 999, 720 is the greatest 6-digit number which is divisible by 24, 15 and 36. Exercise number 2.3, question number 1. The chapter sequence of the numbers and sequence, right? The question number 1, find the least positive value of x such that 71 is congruent to x mod 8. Let's see the first Roman number. Solution. The first Roman number is given as 71 is congruent to x mod 8. See, it is a positive integer and here mod is the divisor and the x value is the remainder terms here in congruent, right? Now we want to find out what is the remainder here. X is the remainder, so we want to find out what is the remainder when 71 is divided by 8. So this can be written in the form of 71 minus x is equal to 8n, some constant, right? So 71 minus x is equal to 8, that the number is divisible by 71 minus x. If what number will be applied here, that number should be subtracted 71, that is exactly divisible by 8, right? So here 71 is divided by 8, what do you get? 8 8s are 64, so the remainder is 7. So the remainder is 7. So you are going to subtract the 7 in 71, then only we get the number, it is exactly divisible by 8. So here the x value is 7. By this we can be able to find out the values. Therefore 71 minus 7 is equal to 8n, right? 71 minus 7 is nothing but 64. 64 is a multiple of 8. 64 is a multiple of 8. So it is divisible by 8 means we get the remainder as 0. So the least positive value, the least positive value of x is 7. Let's see the same solution, another method. See, 71 minus x is equal to 8n. Here 71 minus x is 71 minus x is equal to multiple of 8. So multiple of 8 means, here let me take it as the term 71 minus x is equal to 0, 8, 16 up to number 72, right? 72 is not possible because here we have the highest positive integer is 71, so let me take it as up to the number 64. So 71 minus x is equal to, let me take as the highest possible number is 64. So 71 minus x is equal to, we take as 64, right? From here we take in the term, we want to find the value of x, so I take the 64 to here. 71 minus 64 is equal to, I take this minus x to on the side, we get plus x. When we subtract this, we get 7 is equal to x is nothing but x is equal to 7. Here x is equal to 7 is the least positive value. Either we can, okay, let's see the second Roman number. Here we have 78 plus x congruent to 3 mod 5. The second Roman number is 78 plus x congruent to mod 5. So it is the dividend. So here 3 is the remainder and here 5 is the divisor of the terms. So I take this remainder to this side, we get 78 plus x minus 3 is equal to this mod 5 can be written as 5n, the multiple of 5, right? When we subtract this 75 plus x, 78 minus 3 is 75 plus x is equal to, that is the multiple of 5. Multiple of 5. Multiple of 5 means we know that is 75. We are take that 75 plus x is equal to, the multiple of 5 is nothing but 5, 10, 15, it goes away. Now we want to find the least positive value of x. Here the least positive value of x is equal to, we take as 1, 2, 3 up to the number. Now we have to find the closest number to 75. That number should be a multiple of 5 means here I take 75, then 80 and then 85 like this, right? It goes on. Now if I apply the value of x in this term, 75 after, when we get it is 80, that number is exactly multiple of 5, right? So if I apply x is equal to 1, we get 76 and then 2 means 77 and then it goes on like this. When I apply the value x is equal to 5, we get 75 plus 5 is equal to 80. Here the number 80 is the exact multiple of 5. So here the 5 is the least positive value. Therefore, the least positive value of x is 5. This is the third Roman number, the same sum. You want to find the least positive value of x, right? The third Roman number is given as 89 is congruent to x plus 3 mod 4. See, it is the dividend, x plus 3 is the remainder and here mod 4 is the divisor of the term, right? Now I take this remainder term here. So 89 minus of x plus 3. I take the term remainder here, we get, then multiple of 4. 4n. Let me take as the 4n is the multiple of 4. When I remove the bracket here, we get 89 minus x minus 3 is equal to 4n means multiple of 4. So multiple of number 4. Here 89 minus 3 is equal to 86 and then minus x is equal to the multiple of 4, right? Here what are the numbers multiple of 4? Here multiple of 4 is equal to, that is 86 minus x is equal to, multiple of 4 means 4, 8, 12, 16 up to the number, it goes on. Here we have the number, highest number is, highest positive value is 86, right? Now here we are going to subtract the value of x. When we subtract the value of x in 86, that number should be a multiple of, that number should be a multiple of 4. See, clearly 86 is not a multiple of 4, so we get 84 and then 18, right? So these are the multiple of 4. So here x is the positive value. Let me take this 1, 2, 3, 4. It goes on the value. Now here I am going to apply the value of x in term 86 minus 1. If I put 1 means 86 minus 1 is 85. 85 is not a multiple of 4. So it is not possible. Then I apply the x is equal to 2. Right? 86 minus 2 is equal to 84. So 84 is a multiple of 4. See here we get the multiplication. So 4 into 21, right? 4 into 21 is 1 4 is 4, 4 is 8. So we get the multiplication. So here 2 is the least positive value of x. Therefore, the least positive value of x is, what is the number? 2, right? Students, exercise number 2.3, question number 5. What is the time 100 hours after 7 a.m.? What is the time 100 hours after 7 a.m.? Here we are using the Euclid division or complement modulo to find out the value of after 7 a.m. 100 hours after 7 a.m. Here the complement is A complement to B mod n. Here A is the positive integer, B is the remainder, and n is the multiple of or divisor of this positive integer. Here I take the positive integer as 100 is complement to, we don't know the remainder, so let it take as x and mod. See, the time is actually 7 a.m. and p.m. means it should be divided by 12, right? Not 24 hours, it will be 12 hours only. We are calculating as a.m. and p.m. So when they are asking when time means, we have to divide by 12. Now I take this x to this side. So 100 minus x is equal to 12n. That is a multiple of 12. So 100 minus x is equal to multiple of 12. That means this number is multiple of 12. So here, what is the multiple of 12 means 100 minus x is equal to multiple of 12 is we get 12, 24, 36, 48 like this, right? And then 96 and then 108. It must be goes on like this, right? Now here we want to find the positive value of x. Which number of x if you apply? That particular number should be a multiple of 12. If I take x is equal to 1, 2, 3, 4 like this number, if I put x is equal to 1 in the place of x, 100 minus 1 is 99, there is no 99 is there, so it is not a multiple. Then put x is equal to 2, 98 will be there, right? So 98 is also not there, so it is not a multiple of 12. And then x is equal to 3 means we get 90, 100 minus 3 is 97. 97 is also not a multiple of 12. Then 100 minus 4. Here 100 minus 4 is nothing but 96. See, 96 is the multiple of 12. So the least positive value is x is equal to 4. Here we want to find out after 7 a.m. Right? After 7 a.m. means this remainder should be added at 7. So this is 100 congruent to 4 mod 12. So the time after 700 hours, the time 100 hours after 7 a.m. is, we want to add with the remainder 7 plus 4. 4 is equal to 11 a.m. So we get the time 100 hours after 7 a.m. is 11 a.m.